4.7 Newton and 4.7 Newton. So let's say we have a parallelogram Q, and let's say this is U and this is V. So our U is 10 and our V is also 10 Newton and our P is 10 Newton. So let's find the Q. So 2U plus 2V is equal to P plus Q. 100 plus 100, which is 200 of course, 2 times 100 is 200, 100 plus Q. So Q is square root of 300. So Q is 10 square root of 3. Okay. So now, two concurrent forces. So concurrent means two forces passing through a same point. Two concurrent forces have a maximum resultant of 45 Newton. So F1 plus F2 is 45 Newton, that's max. Minimum of 5 Newton. So F1 minus F2 is 5 Newton. This means 2F1 is 50 Newton. F1 is 25 Newton. So let's use one of the equations from above. F1 plus F2 is equal to 45 Newton. F1 is 25 Newton plus F2 is equal to 45 Newton. So F2 is equal to 20 Newton. So 25 Newton, comma 20 Newton, the force. Now, it's moving the x direction, it doesn't moving in the y direction, we know that. So we only care about the x direction. So, magnitude of the force is equal to force times cosine theta, because cosine theta is because it is moving up to the x direction. So F is 28 Newton, cosine 45 degree. And then we know cosine 45 degree, this is 28 Newton. It's square root of 2 over 2. 8 Newton. Let's do 15. I have a mass. The mass of 100 kilogram. This is 1 times 10 raised to 2 kilogram. Sitting on the track. I want to know, and the track is accelerating 2 meters per second square. I want to know the friction, the force of friction. So force of friction, we're going to simply use Newton's second law because it is at the x direction. ma. And the acceleration is 2 meters per second square. So which is 200 Newton. This is 2 times 10 raised to 2 Newton. On the incline, I want to know the parallel component of the weight. In an inclined plane compared to the flat surface, if a mass sitting on a flat surface, gravity has just one component. That's it. Gravity has one component. However, in an inclined plane, gravity has 2 components. The gravity has 2 components. One is the perpendicular, or FZY, or WY. The Y component of the weight, or Y component of the force, or Y component of the force due to gravity. This is the X component, which is parallel to this line, this orange line, okay? So we call it a parallel, or WX. So the parallel component of the weight is simply parallel component of the weight is RF. Z parallel is equal to FZ sine theta. So FZ is W, sine theta is sine 30 degree, and sine 30 degree is, you know that this is 30 degree. This is 3/2 and this is 1/2. So sine 30 degree is 1/2. So W 1/2. This could be written as 0.5 W. So the parallel component of the gravity is 0.5, whatever weight it is. If I give you the mass, if I say mass is 10 kilogram, that would be 0.5 times 10 kilogram, 9.8 meter per second square. So that would be, if the mass is 10 kilogram, that would be, this is a force vector. Draw a concurrent force. Draw a pair of concurrent force for this guy. Okay, let's see. This is the pair of concurrent force that gave birth to this force vector. Now, I want to draw a pair of concurrent force that would produce equilibrium. So that has to be equal in magnitude but opposite in direction. This is opposite in direction but definitely not equal in magnitude. Aha. This is like 3 times more. It's still not equal in magnitude, but opposite in direction. That's good. So I have to make sure. This is about this size, so this is about this size. Okay. Now, this is equal in magnitude and opposite in direction. Now, I'm going to erase this concurrent pair. I'm going to draw a concurrent pair for this one because that's what the problem wanted you to do. Okay, this is a circular path, almost circular path. A truck with 1,000 kilogram moves around this circular type path. Now, I wanted to find the net force from A to D. From A to D is 0 Newton, is because it's a straight path. This is part A. Part B. I wanted to find the distance from C to B. I'll give you one piece of information. It takes 20 seconds for the car to come from C to B. It is 20 seconds. I wanted to find the distance from C to B. So distance is velocity times time. So velocity is, the car is moving 20 meters per second. 20 meters per second. So 20 meters per second times 20 seconds. So 400 meters. From here to here is 400. So a man is in the elevator and his weight is 800 Newton. And there is a tension force, and tension is always upward force. There is a tension force on the string, that's 600 Newton. So the man is accelerating upward or downward? Let's do the diagram. We did it many times before in the class for the etude machine and for the elevator problem, two mass hanging on a pulley. So I have force diagram. I have mass 1 and I have Ft. There are only two forces acting on this system because the system is accelerating at y direction. It doesn't accelerate at x direction. So m1g minus Ft is what? M1g minus Ft is m1a. No mass, no acceleration. Acceleration, in order to accelerate something, you have to have mass. So this guy is simply F sub z minus F sub t is equal to the weight, m1, ma. So F sub z, you already know that. So F sub z is Ft. Is we going to just write the acceleration. So F sub z is 800 Newton minus Ft is 600 Newton. So A is so F sub z so Ma is Ma. So Ma is 200 Newton. Okay, so if Ma is 200 Newton, Ma is 200 Newton, A is 200 over M. So this accelerating down at 2.45 meter per second squared. So the bottom line is accelerating downward and 2 kilograms. If I apply a force and that gives the acceleration of 5 meter per second squared of box number 1, which is 8 kilograms. Same force, how much acceleration will the same force give to the box that is 2 kilograms? So let's find it out. F equal ma. So F equal 8 kilogram 5 meter per second squared. So 40 Newton. So F equal ma. So 40 Newton. So this acceleration was caused by 40 Newton. When I apply 40 Newton at this box, which is 8 kilogram, that generates 5 meter per second square acceleration. Now let's see the other part, F equal ma. So this is 40 Newton. We want to know same amount of force will generate how much acceleration. Would be more because the mass is less. Let's see. 40 Newton is equal to mass is 2 kilogram and then A. So A is 40 Newton over 2 kilogram. A is 20 meter per second squared. Produce only 5 meter per second squared acceleration. Here the same amount of force, 40 Newton, gave the back of 20 meter per second squared acceleration. So we know that acceleration is proportional to force but inversely proportional to the mass. The bullet is 0.025 kilogram. Unbalanced force is 200 Newton. And the force act is 0.1 second. We have to find the velocity. This is very easy. F equal ma. So F equal A equal delta V over delta T. F equal delta V over delta T. So M delta V is equal to F delta T. So delta V is equal to F delta T over M. So F delta T, F is 200 Newton. Delta T is 0.1 second. And mass is 0.025. So velocity is 800 meter per second.